And let's talk about simplifying trig expressions. Now, with this stuff, I want you to think about this as some suggestions if you're stuck, okay? If you look at the problem and you see it and you go, oh yeah, there's a Pythagorean identity. Oh, I can just cross these couple of things out. Then you don't need these. This is for when you get really stuck. So first thing is, look for Pythagorean identity. How are you going to spot those? You're going to see an operational sign and a squared trig term, okay? If you see that, it's probably Pythagorean identity. Have those identities out where you can look at them, because I'm pretty sure nobody's got them all memorized yet, okay? So having those available to look at will help you. Next, if it's not a Pythagorean identity, then look at the reciprocal identities. You might want to try doing some factoring. We'll see some of that. Or maybe multiply some stuff together. If you have tangent, cotangent, secant, or cosecant, and you're stuck and you can't figure out what to do with them, an easy way to kind of power through a problem is just rewrite everything in terms of sine and cosine. All right? So try and look for those things. They will help you out. Are they always going to be the solution where you go 1, 2, 3? No, but you want it helps you kind of like think like, how can I attack this problem? All right, let me let that person into class. All right, and let's take a look at some example problems. All right, so hopefully when you look at this, well, let me see if I can make it a little bigger. Hopefully when you look at the first problem, you look at it and you say to yourself, ooh, that is it. Okay, that's just moving everywhere. Hang on. All right. So hopefully when you look at the first problem, which is 1 minus sine squared theta over cosine squared theta, hopefully everybody is seeing that Pythagorean identity. Now, if you don't have all your identities memorized, and this goes for people here and at home, get them out so you can actually have eyes on them. Why make things harder on yourself? Have them out there where you can see, okay? All right, so if you're looking at this, hopefully everybody's looking at that and going, okay, there's a Pythagorean identity. What is that equal to?
That's equal to cosine.
It is cosine squared theta. Thank you so much. And then your denominator, that's already in terms of sine or cosine, so I'm not going to rewrite it. Okay, you rewrite stuff to get it into sine cosine. And you'll notice your numerator and your denominator are the same, so those reduce, simplify, cancel out, you're left with 1. Does anyone have any questions either here or at home about A? Then let's take a look at B. So B, I see operational signs, but nothing is squared. So that means you can't use a Pythagorean identity unsquared, folks. You can't use a Pythagorean identity unsquared. So if I look at that algebraically, do you notice that one parenthesis has the same stuff, but it's plus, and one has a minus? That should kind of remind you of when you factor difference of squares. So we're going to unfactor that using FOIL. So I'm going to multiply the first 2 terms, and I get a 1. I'm going to multiply the outermost terms in the parentheses. So that's the 1 and the cosine. So I get cosine of x. Then I'm going to multiply the innermost terms, and I get negative cosine x. And then I'm going to multiply the last term. And I get negative cosine squared x. Do you notice that the unsquared terms cancel out with each other, one's positive, one's negative? Now I want you to look at that and see if you can spot the Pythagorean identity. What's it equal to? What do you think? Yeah, sine squared x.
I talked too much.
It's okay. I appreciate that. All right, so before I erase anything for A or B, does anyone have any questions about either A or B? Okay, remember, I'm happy to explain what my thought process is on it, what I'm seeing that you might not be seeing. I'm happy to answer any of those questions so that I can make sure that you're getting the best possible experience out of this. Okay. And let's move on down to C and D. Come on, C. Okay, so that first column, C, it has a minus in it, which makes me automatically think Pythagorean identity. But are there any Pythagorean identities that look like that? So look at your list. Do any of them look that way? And even if you rearrange it, does it look that way? No. So that means I'm going to try rewriting everything in terms of sine and cosine. It's a little bit brutal, but a lot of times it'll work. So I'm going to go down to that list of reciprocal identities, and anything that's not written in terms of sine or cosine, that's what it's going to get. So my first piece becomes 1 over sine of theta. By the way, if you don't want to write theta and you prefer to write x, go ahead and do that. My second piece becomes 1 over cosine theta. I'm going to put a little multiplication sign there just to remind me that I'm multiplying. Over on the other side, I've got cosine of theta over sine theta. Now, anytime you have two fractions that are multiplied, squish them together into a single fraction. Doesn't. Okay, so you get to this point and it still doesn't look like a Pythagorean identity, but you have two fractions with different denominators. So you want to think to yourself, how can I make this into one fraction? Because a lot of times when you do that, the Pythagorean identity will appear. So my first, yes?
Could you multiply by cosine over cosine?
Mm-hmm. So my first denominator is sine cosine, and my second one is sine. So in order to make them both sine cosine, this term needs a cosine cosine. And if you notice, when you do that, you have just made the numerator into a cosine squared theta, because cosine cosine is, of course, cosine squared. And my denominators are going to be the same. Now, I'm going to put in one extra step that some of you may or may not need. I just want to make sure it's all out here. No confusion. Try not to leave anybody behind on this. So I got two fractions with the same denominator, which I can then put together into a single fraction. And hopefully at this point, you see the Pythagorean identity that we just created. Now, when I start a problem, I don't know exactly how it's going to go. Okay, now this one I do because it's my third time doing that same problem. But when I start a problem that's totally fresh, I haven't seen it in a long time, or haven't seen before, I don't necessarily know where it's going. Do you see that Pythagorean identity in the numerator? Then please replace your numerator with what that Pythagorean identity is equal to. Now let's talk about this. If I had x squared over x, would everybody agree that's x? No. Same thing is true with your sines. That means that there are two sines multiplied together, and this is one sine. So I'm going to cancel out one of those sines. And the way I typically do that is just like if you had powers with exponents, you change the power, because you still have one sine at the top. So now you're left with sine over cosine, which hopefully everybody knows at this point, because you're getting really comfortable with at least that identity, that's tangent. Okay, before we move onward, you need to have a little discussion about order and neatness. Now, I know that many of you in here do not have this problem, okay? So if this is not you, I'm not talking to you. If a teacher has ever said to you, I cannot follow your word, I don't know what you're doing, and I don't know where this is going, you're going to need to put some arrows into your problems. So if you are a person who consistently just kind of goes straight down the line, and then maybe they go to the right, but there's always equal signs, and you can always follow your work, you are good, and I'm not talking to you. But if you're the person who starts here in the middle, and then goes over there because there's some empty spot, and then they go down over here, I need to know where you're going. So leave me a breadcrumb trail with some arrows if you don't go in a linear way with your problems, okay? I want to squash you and say, oh, you can't do that, but how about some arrows just to help me out with that? And again, if no one's ever said anything to you, then you are not a problem, okay? So don't stress about it, just go, I'm doing it right. All right, anybody have any questions about C? Anything at all that's throwing you off? Any step up here that's not 100% clear to you? All right, let's go to D. So I'm hoping that when you're looking at D, that everybody in here is seeing two different Pythagorean identities. Can you replace both the numerator and the denominator with their Pythagorean identities?
Yeah.
Then please do it. Now, I would like to point out right here that cosine and cotangent are not the same thing. And if you cross them out because all their differences is one letter and you write down 1 instead, you have a mistake. So please be careful about stuff like that. So at this point, that looks pretty good. But it might be a good idea if you tried a reciprocal identity. What were you thinking?
So I turned cotangent into cosine over sine, and then I brought the sine up to the first and made it into sine of x times cosine of x over cosine.
My square's in the wrong spot. Okay, that is an excellent approach. So Cole was able to kind of visualize where his sine was going to end up in the top. And as you get better at this, you will be able to do that too. But let's say that right now you're not 100% sure if that sign is going to end up in the bottom of the fraction or the top of the fraction. Don't take a chance. Remember, you can always do numerator times the reciprocal of the denominator so that you can be 100% sure where things are going to go. So that's cosine squared x times sine squared x over cosine squared x. And as you can see, your cosines are going to cancel and you're going to be left with a sine. Now you'll notice that when I cross out my cosines, I just put one line in them. I do not like scratch them out on the paper like they never existed. Please don't scratch out your work to such an extent that I cannot visibly read this line anymore, okay? I know some of you are feeling really powerfully and strong about crossing out stuff and it feels good, but make sure I can still read the line above, all right? If you can't see it anymore, you probably scratched out too much stuff. All right, any questions about either C or D? Okay, so C, D, A, B, those were all pretty straightforward, and there was really kind of only one clear direction to take on those. The next two problems, though, there is a divergent path. So on problem E, I would like you to give problem E an attempt. There is one way, which is short, and there is one way, which is long. You will know that you have reached the end of the path when you find that your answer is negative cotangent cubed x. All right, so you will know that you got to the finish line when you get there. Now, this shorter path takes about 3 steps. The longer path takes about 6 or 7. But both of them work. Please give it a try while I'm letting this person into class. I'm gonna write out the really long way on board. If you don't want to see it yet, don't look up, okay? If you don't want to see it yet, you don't have to look up. Okay, what if you did it a different way? Please don't erase your work. Remember, this is the long way to do it. There's another way to do it. All right, so if you're going the long route on this one, and again, the only reason that it's the long route is just because it takes more steps, but you get to the right place, and yes, I will show you the shorter path. I just rewrote everything in terms of sine and cosine. It's a blunt instrument, but it works, okay? So if you're sitting there staring at something and you can't figure out where to go, do that. At that point, I noticed that my denominators, I'd like them to be the same. I'd like them to both be sine cubed x. So I multiplied the top and the bottom by sine squared x, which gives me these two fractions. Once the denominators are the same, I can put the fractions together, okay? So that's what you see from here to here. I then noticed that it's a binomial with a cosine, so I factored the cosine out. And then I kind of hit a little bit of a snag, because if you look on your sheet with all your identities, the identity for this term is 1 minus sine squared x. So 1 minus sine squared x is going to be cosine squared x. But if you reverse the terms, kind of an old way of doing things that they probably mentioned back in Algebra 1, if you just want to flip the terms around, if you multiply by -1, it reverses their order and their sign. So when the reverse order is there, I make that negative cosine squared x, which makes that negative cosine cubed x, and cosine over sine is cotangent. And in this case, negative. What kind of questions do you have about this long path to do that?
We see the shorter way now.
Yep. All right, so the shorter way, the only reason I thought this direction is because I noticed this was a binomial where both terms had a cotangent. So the first thing I did was factor out the cotangent. And then I looked on my sheet with all my identities, and I noticed that my identity was cosecant squared x minus 1. Well, if you flip it around the other way, it just makes it negative cotangent squared x versus being positive, which makes that negative cotangent cubed x. Yeah. Sometimes there's a shorter path, sometimes there's not a shorter path. Like sometimes any path you take is long. This one was just kind of an extreme example of if you happen to catch it, you can save yourself some time. What if you didn't? Notice that both of these problems have a correct answer. All right, you don't have to do it the shorter way, you just got to do it. All right, so either in class or online, does anyone have any questions about either parts of E? Because I'm going to have to erase that part of E that's under F before I can talk about F. Anybody online have a question about E? Anything at all from E? All right, then let's go to our last example that we have today. And let's start off with how not to do it. Not the right answer. Okay, so let's talk about why it's not the right answer. So your denominator that you have down here doesn't just belong to the front half of this binomial, it also belongs to the back half of that binomial. So remember when you're doing fractions and you put them together, like over here, where we put those fractions together, even though we only wrote the sine cubed x once, it actually belongs to both the first term and the second term. So be careful when something looks that obvious and then it's just like, bam, I'm done. Even with the shorter method that I had to do 3 steps. So if you literally are finished in 1 step and it looks that complicated, you probably did something wrong. So when you're thinking about this, it's really secant of x cosecant of x over secant of x cosecant of x minus tangent of x over secant of x cosecant of x. Now, of course, that first fraction is 1. So you were 100% right about that. It's the second fraction that's the issue. Now, with that second fraction, what you want to do is use your reciprocals, like everything in terms of sine and cosine, and then you should be able to find your answer pretty easily. So I'm going to start with the numerator. The tangent is sine of x over cosine of x. And your denominator is cosine of x, sine of x. All right, did I lose anybody? Is anybody confused about what I just did? I can put in an extra step if you want it or need it. Okay, so here's my numerator right there. That's the tangent replacement. And these two pieces are replacements for the secant and the cosecant. Any questions? Okay, now if you're 100% confident, because like in your mind, you just know how all that's going to work out, that is fantastic. But let's say that you're not 100% confident when you have weird trig fractions. Remember, numerator times reciprocal of denominator will not fail you. So your numerator is sine of x cosine of x, and your reciprocal of your denominator is cosine of x sine x over 1. Now, you notice, hopefully, that there's a cosine in the numerator and the denominator. You want to get rid of those. And what's left will be sine of x times sine of x, which is sine squared x. And all of a sudden, you should see a Pythagorean identity that just appeared out of nowhere. So you can write your answer as cosine squared x. So notice on that problem, I used a lot of different math. I used all those reciprocal identities. I used the Pythagorean identities. I did stuff with fractions and common denominators and simplifying and all of that stuff. All right, what kind of questions do you have about E or F? Okay.
We're really getting into the time of math doesn't have numbers anymore.
Yeah, we're there for a while. There's numbers in this unit, just not right here. I mean, there's exponents.
One is in there.
What?
One is in there.
Yeah, exactly. There's a number. All right, so let's take a look at what your day 2 homework is. You'll notice there are 14 problems. Now, yesterday I basically said you can work any of those as long as you work half of them. Today I'd like you to either work odd or even. The reason for that is that I want to ensure that everybody does some problems with reciprocals and everybody does problems that involve the Pythagorean identity. Because of the way this paper is written out, it would be possible to completely avoid one of those types. If you carefully selected, you could only do Pythagorean identities, or you could only do reciprocals. And I want to make sure that you do some of each. The other thing I want to point out is, I'm sorry, I got a little crazy with the letters on this one. So if you look at problem 6, there's an alpha. You can write alpha as X. And if you look at problem 7, I don't know what I was thinking. I put a beta in there. Again, you can use an X. Okay, these are just other Greek letters that can be used. Or you can use an X. All right, so pick the letter of your choice if the beta or the alpha bothers you. All right. Okay, so remember, odd or even. I'll post the answers for the whole thing for you before I leave school today, so I'll do that during 6th period planning for me. If you have any questions, let me know. Otherwise, do some practice problems.